G'day guys. So in this video, I want to continue talking about how we develop our base plan for the permaculture design project as part of Northeast Street's permaculture design course. There's a few things I want to go through in this particular video related to map scale and fitting your site at an appropriate scale onto A3 paper. So, yeah, I'm going to talk about map scale. I'm going to go through what that means. I'm going to talk about how you orient a drawing onto the page. Okay. It's all about the north point, which way the north point runs. I'll talk about that. I'm going to talk about standard scales. There's sort of some conventions about what standard scale should be, and then the main piece of this video is about fitting your site on A3 paper at an appropriate scale. Okay, so map scale. So let me just share another piece of screen with you. And we'll go into day 3 of the online course resources. I'm just going to flip into, hopefully, the next page. So in day 3 of the course resources, there's a whole lot of stuff, including a couple of documents about map scale. Okay, so in this document here, which is just called scale, it tells you all about why we do scale. Okay, so have a read of that document. Get familiar with what scale's all about if you're a bit unsure, but I'll read the first paragraph. So one of the most important characteristics of a map, which is what you're going to create, a map or a plan, is that it enables the reader to measure distances between mapped features, okay, using a scale ruler. However, maps are necessarily smaller than the areas they represent and must state the ratio between the comparable distances on the map and what's actually on the ground to enable accurate measurements to be made. And this ratio is known as the map scale. Okay. It's really important that you sort of understand this when you're putting together your project. I've seen so many students get very confused about map scale. Um, so just familiarize yourself with that. I'll go back to the camera again. And I'll talk a little bit about drawing orientation. Okay. So say this is my A3 page this is the edge of my A3 page. Okay. On all plans, you'll notice, well, you should notice, otherwise they've been done incorrectly, is they'll have a north point. They'll have an arrow that looks something like that. Um, or there's a whole lot of nice ways to do north points. There you go, various different ways to draw north. Uh, the sort of convention is that north always points upwards. Okay, it might point directly up the page like that. It might point to the side, but still sloping upwards. Or it may indeed need to be fitted so it's horizontal. You know, that's north. Okay, that's our north point. But it's never pointing down. Okay, never draw a plan where the north point points down. Okay, that is wrong. Don't do that. Okay, so I'm going to write here, north is always upward. on the page. Okay. And I'll just bring this back again. You can do north points in various different ways. This is some really lovely ways to represent north. Okay. So let's make sure you get that right. Sometimes we have to actually have our north going sideways or sloping upwards simply because we're trying to fit our site onto the page. Okay. Um, so that's a little bit about drawing orientation. So standard scales. All right. So there's sort of some drawing conventions in architecture and landscape architecture and engineering and surveying around standard scales. So for the sort of work that we're doing at the residential suburban level, um, these are the sorts of standard scales, right? 1:50 is a standard scale. 1:100 is a scale, standard scale. 1:200. 1:250. They're the sorts of scales you'd probably see at a suburban level. If you're working on a farm or a much bigger property, we start getting into perhaps 1:500 or even 1:1000 and beyond. Okay, so they're sort of standard scales. Sometimes I see students do 1:125. That's acceptable too. Okay, but 1:300, 1:400. No, not really. 1:550. No, they're not standard scales. Okay. All right. So when you're thinking about sizing up your drawing, try and go for those sorts of standard scales. Okay. And here we have a scale ruler, and it's got various different scales on it. Okay. Um, including 1:200, 1:100, 1:250, 1:500, that sort of thing. Okay. All right. So that's a little bit about standard scales. So let's get into the meat and potatoes of this video about fitting your site onto A3 paper at an appropriate scale. How do you work that out? So let me go and share screen again. Okay. So I tab across. I've logged into the Queensland Globe portal. In a previous video, I showed students how to log into the portal and pull up their site that they're working with in order to get the boundary measurements. That's just one method of finding the boundaries of your site. And you may recall from that video, I concentrated on this particular site in the middle of the plan. So I'm just going to continue onto um, this site, which is shown in the middle of the screen. And you may also recall we used the measurement tool um, to do some measurements. So I'm going to do the same measurements again as we did in the previous video. I just wanted to show you and remind you of the dimensions. And I'm going to write down these dimensions in a minute. So about 40 meters long and about 20 meters wide. So if we jump back into our over the top camera, our site was 40 meters by 20 meters, wasn't it? Okay. Now we want to convert that measurement into millimeters. Okay. It needs to relate to the size of our sheet. So 40 meters is 40,000 millimeters. Okay. There's 1,000 millimeters in a meter. So 40,000 millimeters by 20,000 millimeters. Okay. Um, yes, there's 1,000 millimeters in a meter. So 1,000 millimeters equals 1 meter. Perhaps this is bringing back some memories of your high school geometry. Maybe not so good memories, but this is the sort of thing we just need to know a little bit about when we're putting together our base plan. Okay, so that's the size of our site. Okay, it was on a slight angle, 20 meters by 40 meters. Okay, so the next thing to do is to have a look at our A3 sheet. Now, an A3 sheet is 42 centimeters or 420 millimeters by about 30 centimeters or 300 millimeters. So our A3 sheet, um, 420 millimeters, okay, by 300 millimeters. Okay, so that's the A3 sheet. This is our site. All right, so how do we work out the scale? Well, we want to allow a little bit of margin on our sheet. We don't want our site to be going right to the edge of the sheet. We want at least a little bit of margin. So I would be allowing for margin. I would be saying at least 1 centimetre. Um, and in fact, for the purpose of this exercise, we'll just go with 1 centimetre because it makes the calculation a bit easier. So if we take 1 centimetre off, then the sheet size we're really working with is so 1 centimetre around all of the whole page. Um, we're working with 400 millimeters by 280 millimeters. Okay. How do I work out the scale? So we work out the scale for each side of the sheet. And all I'm simply doing is dividing the 400 into the 40,000. So 400 into 40,000 equals 100. And you can do this with a calculator if you need to, guys. Um, and 280 into 20,000, a little bit more tricky, is about, let's see if I get this right. You can check to see if I've got this right with your calculator, but I think it's about 62 or 60 or something like that. So that'll be the scale for the width of the sheet. And so what you simply do is pick the largest number, and that gives you the scale that you need to be working with. So in this case, 100 is the largest number. And so what we're going to work with on our sheet, on our A3 sheet, is 1:100. Okay, that's going to be our scale. So if I bring my A3 sheet and I'm going to be working with, I'm going to have a 1 centimetre margin all the way around, and I can fit my sheet um, on there, bearing in mind that that's north. Okay, there's our north. Can recall from Q Globe. and we're at a slight angle off north. So I would be, if this is my sheet again, my A3 sheet, I would be drawing this particular plan on so that the 40-meter length is along there and the 20-meter length is along there. So that's my property. Okay. So that's 40 by 20. And north would be, therefore, on that slight angle. Okay. And we can get very accurate with that. We can go back to Q globe. Let me do that for you. What should that angle be? We can check that. You can even check it with a compass on the ground. Or we can go back to our measurements. Now recall, just have a look in the bottom left of screen. As I measure this, you'll see a figure called bearing comes up. So all bearing is the angle relative to true north. And so the bearing shown here, double click on that, is about 9 degrees, as you can see, about 9 degrees down here. All right. So we could indicate our north very accurately in that way. If we go back to the overhead, um, if you wanted to, you could really make sure uh, you got that angle right, 9 degrees, by using a protractor. I've got a protractor here with me right now, but if you wanted to, you could pull out a protractor and get that quite accurate. So that's the way I would size that drawing up on the sheet, but with a very limited margin. So I'd only have about a centimetre or 10 millimetres, you know, from there to there. That might not be enough for you. You might want to actually um, go for a smaller scale. So rather than 1:100, you might want to consider 1:125, which is sort of a standard scale, or even 1:200. Okay, 1:200 is half the size of 1:100. Okay, so that drawing would become essentially that side would eventually be would effectively be half the size on an A3 sheet. Okay, so that's how you would fit your site onto an A3 sheet. Now remember what scale is all about. All a scale is saying, say for 1:200, is it saying that 1 centimetre on my A3 sheet actually represents 200 centimetres in real life. Okay, that's what scale means. 1 centimetre represents 200 centimetres, for example, or 1 metre represents 200 metres on my A3 sheet, if that's the scale I'm choosing to go with. All right. Just to finish up, let's just recap by looking at some of the online resources again. So I go back to the example that's shown in the online resources. So it's pretty much very similar to the way I've gone about doing the calculation beforehand, the example beforehand using Q globe. Here's another example here. So let's have a look at that. Okay. And there's a practice example that you can have a go at as well. So have a go perhaps and give me some feedback, see how you went with that little exercise. All right. And then to this document, it's also on day 3 online resources. We'll scroll down and I wanted to show you different ways of representing scale. So you can do it in 3 different ways. You can use a scale statement. Um, so for example, 1 centimetre equals 1,250 meters, or 1 centimetre to 300 kilometers. That'd be a huge scale. That's a very big plan. That's sort of, fitting the state of Queensland onto an A1 sheet of paper. All right. The other way you can do it is with a graphic or bar scale. That's a very common way for people to represent scale. You can do it that way, or you can just say, just put up the scale as I've been showing on the example I worked through. 1 is to 250. So 1 unit on the map represents 1,250 units on the ground. Okay, guys, so there you have it. There's a bit of an introduction there to the scale and how to fit your site onto an A3 sheet of paper.